There are many confusions out there about processors, threading, dual-core, quad-core, nanometer technology and cache memory. In the early days of computer processors, they were single-core, meaning they had just one central processing unit inside the chip. As technology progressed, the distance between tiny transistor and the chip decreased. This paved the way for the addition of another microprocessor, transferring the chip into a first dual-core processor. With ongoing achievements, processors become even more powerful and efficient. They introduced quad-core, octa-core and multi-core processor even with more cores. For example, Intel's latest series features a 10 nanometer size with 24 cores and 32 threads, meaning it has 24 physical processors integrated in one chip. Threading technology like Intel's hyper-threading doesn't physically divide the processor. Instead, it divides tasks based on performance needs. This is particularly useful during multitasking, as users started running more complex tasks simultaneously, such as editing videos and playing games, which is overwhelmed single-core processors. Dual-core processor addressed this by allowing each core to handle different tasks independently, resulting in smoother performance. Computer exclusively process binary code consisting of ones and zeros. A straightforward explanation of a microprocessor is that it is composed of billions of transistors, each tasked with carrying out various operations in unique and allocated manner. A single transistor comprises an emitter, base and collector. When a current flows through this circuit, the emitter emits electrons which are free electrons. If the base accepts these electrons, which contains holes, the value is 1. If it doesn't allow them into the base, the value is 0. Another simplified way to comprehend this is by associating 1 with lights on and 0 with lights off, highlighting the binary essence of computing. In this system, data is represented using ones and zeros, forming the foundation for the digital computation. This concept evolved as technology advanced, from vacuum tubes to transistor and integrated circuits. After the integrated circuit era, the microprocessor era began with the Intel 4004, marking the world's first microprocessor. It featured 2300 transistors. Unlike today's processor, it didn't have multiple cores and generation or threading capability. It was a single core processor. As technology progressed, the distance between tiny transistor and the chip decreased from 130 nanometer to 90 nanometers, allowing for more efficient packing of components inside the chip. This advancement paved the way for the addition of another microprocessor, transforming the chip into the first dual-core Intel processor. The Intel Core lineup began in 2007 with the first generation introducing i3, i5 and i7 processors. Later in 2018, with the 9th generation i9 processor was added. This processor was introduced in different years and represent different types of performance. This all supports 64-bit computing. The Core i3 represents entry-level performance, featuring dual-core or quad-core configuration, which supports for 2 threads for core. Core 5 offers mid-range performance with quad-core configuration and support for 4 threads for core. Core i7 provides high-end performance, offering quad-core, hexa-core or octa-core configuration with support for 8 threads for core.